Something that's going to be very important in this class, which isn't really physics, it's more of a mathematical tool or an organizational tool, is a concept of a vector. So we have to talk now about what vectors are. And let me just start out by talking about that by talking about the number 5. Now 5 could be a number that can come up in many contexts, just about anything. We could be 5 o'clock, we could have 5 pairs of socks, there could be 5 balls in front of us, or we might be traveling down the road at 5 miles per hour. There's a lot of ways that 5 could be used. In a form like this where there's just a 5 there, it turns out 5 is something just called a scalar. It's just a number which represents, say, like I said, the number of socks or the number of balls. Now, where we might need a vector, for instance, is suppose we had a car here. I'll draw sort of a bird's eye view of the car. There's the top of the car. Here's some wheels for you here. And say the car is going this way with a speed of 5 meters per second. Now, going to the right like that is certainly a direction. We can firm it up just a bit more by thinking of a good old compass like that, where this is something like north, east, south, and west. If you want to be mathematical about it, you can think of this as the east as the positive x-axis and the negative x-axis, and the positive y-axis and the negative y-axis. There's a lot of ways of orienting yourself when you're using a sheet of paper. So this car would be traveling 5 meters per second east or 5 meters per second along the positive x-axis. Either way is fine. But either way, whether you say east or the positive x-axis, you are now specifying a direction. So if we want to know the full sort of velocity of this ball here, we would say 5 meters per second east. Now, as soon as you supply a direction like that, the east is attached to the 5 right there, now you're talking about a vector. It's no longer a pure number like the 5 anymore. It doesn't just count socks or balls. It says that something's moving at 5 meters per second, but now it has a direction attached to it. And for instance, 5 meters per second east is different than 5 meters per second west or 5 meters per second north. So we need a way of sort of containing and handling these numbers, and that's exactly what vectors are used for. So it turns out that in this class and in science in general, there's 3 ways of reporting vectors. Let me just take you through them here so you'll be familiar with them. The first way of reporting a vector, say number 1 here, is just the way we've been talking about. That's sort of called magnitude angle form. And it's just the way we've been talking about it. Or instead of saying angle, I could say magnitude, say, and direction form. And it's exactly what we were saying. You could report the speed of the car as 5 meters per second east. So every time you do this, you're reporting a magnitude, which is the strength of the vector in question, say, in this case, the velocity, and the east, of course, is the direction or the angle. If you're not comfortable with thinking of east as an angle, think of it like a direction. But of course, if we want to report like an angle, which we'll do in some problems here, the east might be something like 0 degrees with respect to the positive x-axis, because that's exactly the same as east. Very mathematical way of reporting, say, this angle here, but it would be the same nonetheless. But in either case, in magnitude angle form, you're always reporting the number of the vector and the direction. The second way of reporting it is, say, in this notation called IJK, or X, Y, Z notation. And the way that notation works is you report the components of the vector directly. So I here always refers to X, J always refers to Y, K always refers to Z, or if you prefer, you can just use the X, Y, Z notation directly. Sort of depends on the book you're using, the class you're using, and even you're taking, and even the professor. So in this case here, the velocity could be represented here as, say, 5I hat plus 0J hat plus 0K hat. And of course, if you wanted to, these ones with the zeros in front, you could just leave out. What does this mean? It means that you have a velocity, and you should probably put the arrow over it indicating that now it is a full vector. You have a velocity that has 5 units along the x-axis, which is exactly what we have in the problem running up here. It has no component along the y-axis and no component along the z-axis. So in this form here, you just look at the vector directly, and you can just pull the components right out. Again, x, y, and z. That's the IJK notation. Notice I'm not putting dots above the I, J, and the K. These are little brackets like that indicating little halves. These are like placeholders for the vectors. I always refers to X, J always refers to Y, and K always refers to Z. The other way it can be reported then, if you want to just use a more familiar notation, is you could say 5X hat plus 0Y hat plus 0Z hat, something like that. All of these are equivalent ways of representing the same speed of the car that we have up here, indicating the magnitude, the 5, and the direction by the placeholder, the X hat. The last way of doing it, which you typically see in calculus and math books, is you can also report the velocity vector just using this so-called ordered set notation, where you can use a bracket like this and just say 5, 0, 0. Very compact, it's succinct. Again, it's called the ordered set notation. The brackets here definitely contain the vector, sort of like a set. You put them in order here. The first one is always the x component, the second one is always the y component, and the last one is always the z component. So all three of these ways of reporting the vector are exactly the same. There's nothing different about them. One does not contain more information than the other, but they are three ways of reporting a vector then. So lastly then, I just wanted to show an example of how you report a vector that was not so cut and dry as this one, which just involves a car traveling straight east like that. So suppose we're working on a problem where here's sort of a reference coordinate system for you right here, and suppose for whatever reason, whether the result or some initial condition was given, I don't know what the situation can be, but there was an object that was going here, say at 10 meters per second, and say it was making a 37-degree angle here with respect to the negative x-axis. So again, this is the x-axis, this is the y-axis. Alternatively, this could be north, east, south, west, whatever. We'll just do this one in terms of the x-y axis here. So how would you report this as a vector? Well, the first way is probably pretty straightforward here. You could say the velocity of this car or object or ball, whatever happens to be going here, is going at 10 meters per second, and you need to be very specific now about what this angle is right here. So you could say that's reporting in a couple of ways. You could say 10 meters per second at 37 degrees, we'll say clockwise from negative x. That'd be a perfect way of reporting. Very unambiguous. You know exactly what the speed is here, and by saying 37 degrees clockwise from minus x, well, where's minus x? Over here. That's the negative x-axis, and clockwise means the vector is coming up like this in the direction a clock would travel, so it's very unambiguous that to find the direction of it, you would go 37 degrees clockwise from negative x. Another way of reporting it, you could say that v is 10 meters per second at 143 degrees, and you could say something like with the positive x-axis. Normally we're comfortable with measuring angles relative to the positive x-axis, so if this is 37 in here, this angle in here would be 143 degrees, 143 degrees, something like that. So 10 meters per second at 143 degrees with the positive x-axis. Here's a positive x-axis this way. That's the way we like to orient things. And you have to sweep out 143 degrees all the way over to there in order to find out exactly where your velocity vector is. Again, this is way one of reporting a vector, the magnitude angle form. If you wanted to use either the IJK or the ordered set notation, you would now have to find the vector components first in order to use one of those. That's something that we need to sort of get good at using here, and you can do that by constructing a right triangle around the original vector. So here's the legs of the right triangle right there and right there. And if you look very carefully here, if this is the 10 meters per second here, this is going to be the x component down here because it's along the x-axis here. This is going to be 10 times the cosine of 37. That's how you would find out how much of this vector is along the x-axis. Likewise, this arrow over here is going to be 10 times the sine of 37. That's how you'd find out the y component. So you can sort of put those numbers into your calculator to figure out what they are here, but 10 times the cosine of 37 is 7.9, and 10 times the sine of 37 is 6. So being at 10 meters per second and 37 degrees, the way this one is oriented here, means it has 7.9 units along the x-axis, 6 units along the y-axis. So if you want to report that now in IJK notation, you could say then that the velocity vector is equal to 7.9 I hat plus 6 times j hat. And now you have to be very careful with the signs because the 7.9 actually points in the negative x direction, so yes, you would put a negative sign right there. And negative 7.9 I hat plus 6 j hat is exactly the same as what's reported in number 1, 10 meters per second at 37 degrees, but you just see the components directly. So that's the IJK notation, and that ordered set notation, you could report this velocity like this, as a big bracket like that, negative 7.9, 6, and 0. Those will both be the equivalent ways of reporting the vector. So lastly then, I just wanted to point out that, emphasize once again, that both of these notations, this one and this one up here, this is probably the most sort of intuitive and clearest one to interpret, but these three ways of reporting the same vector contain identical information. 10 meters per second at 37 degrees, 10 meters at 143 degrees is exactly the same amount of information as minus 7.9 I hat plus 6 j hat, or minus 7.960. There's nothing better about one or the other. One isn't necessarily more helpful or useful or has more information content. It just sort of depends on how you're attacking your problem and what you would like to do with the vectors. But there's three ways of reporting the same vector. All of them are good. There you go.